Now the next script we're actually going to work on is the script for our ball, and there's quite a bit of stuff that we can actually do with the ball. I'm going to try to keep it very simple, very basic, easy to understand, and keep it open enough that you can actually extrapolate on it a little bit later. So to start off with, I'm actually going to select my ball game object here, and I'm going to go ahead and start creating a few things. The first thing I want to look at is actually a rigid body. I want to come down to the constraints, and I want to set freeze position on the Z. This way here, it cannot move off of the whatever position it is at Z. And in this case, we have it set to zero. So we don't have to worry about it drifting to the positive or negative 0. And just for good measure, I'm going to lock the rotation on X, Y, and Z so it doesn't actually rotate on any of these axes. I'm going to come up, I'm going to turn off use gravity, and I'm going to set angular drag to 0. I'll leave the mass to 1 for now. Everything else I'm going to leave the same. I'm just going to shrink that down, and I'm going to go ahead and create a new script. And we'll make it a C# script like usual. And I'm just simply going to call this script ball. And we'll open it up. And whoops, there we go. We have our ball script, and there's 3 values I want to have right at the very start, and I'll make them public. At least, we'll keep them all public now just so we can watch them. The first one will be a float, and it's just going to be min speed. And let's start that off. I'm just going to say 15 for now. We might want to adjust this. And public float, of course, a max speed, and we'll just set that to 20. And of course, it should go without saying that this is the maximum and minimum speed that the ball can move. And I'm going to create another one, and I will make it public for now, just so we can actually watch it in the inspector instead of making a debug log statement somewhere. At the end, you'd want to switch this over to private, because I don't really see a need to expose this to any other script. But it is float, maybe. And I'm just going to call it curve speed. And I'll just start that off at 0. And that's pretty much it. Now, I am going to be doing a little bit of physics in here. And I like to do all of my physics in the fixed update like Unity recommends. So I'm going to create that function as well. And one other function that I want to add that Unity actually includes for us is the on-collision enter. And this one here actually has a parameter of collision, or of type collision. And I'm just going to call this variable col. And that's just lets us know what we collided with. I'm going to want that to be able to speed things up or possibly slow things down. I guess to start off with, let's just throw a debug log statement in there just so we know what we collided with. So I'm going to say debug.log. And inside, I'm just going to say hit colon. And then I'm going to take what we hit, which was col. And I want to get the name. Now, we can't get the name directly, but we can actually grab the game object from the collision and get the name from that. So it's just going to tell us what we hit. And I forgot my plus sign here. Of course, you could use the string format. It's a little more efficient, but I'm probably not going to be keeping this line in here anyway, and it was faster to type. So I'm just going to leave it like that for now. Quickly look over. We're going to need a starting velocity. So I'm actually going to come down here, and I'm going to grab the rigid body. And I'm going to want to go ahead and set the force that it starts at. And I'm going to start off with an add relative force right here. And the new relative force that I actually want to add is going to be a new vector 3. So the direction I want to send it on. And I just want to make sure I get everything lined up here. All right, and I'm going to want to send it on an X, Y, and Z. And we already know that we don't want to move on Z. I'm not going to start off by moving on X. I'm just going to actually start off moving on Y, and I'm just going to move upwards. So I'm just going to start off with my min speed. And that should be good to actually get it started. So I'm going to go back in, grab my ball, and we'll just drag that on, and we'll start it up. Nothing too spectacular should happen. We notice it's drifting up, it hits, and it stops. That seemed a little slow. I actually want to watch the current speed. We actually are not doing anything with the current speed. So let's go ahead and hook the current speed up. And I'm going to go ahead and put that down in the fixed update. And all I'm going to say is current speed is equal to vector 3 dot, and I want to get the magnitude of my rigid body velocity. Make sure I got everything lined up with my parentheses here. We have no error, so I'm going to start this back up. I'll hit clear. And of course I hit clear just as it collided, so we'll just do it again. And we'll notice it has a current speed of 0.3, nothing that spectacular. When it hits, it stops. And we get the little message here. That's great, but let's actually add some code that will actually get it up to the speed we actually want. This is fine for starting it off, but it's not what we want it to. It just basically gets it moving for us. I want it a little bit more than that. So what I'm actually going to do is come down here, and I'm just going to say if our current speed is, I guess, greater than max speed. So if we're going actually faster than the speed that we actually want, what I want to do is grab my rigid body and get the velocity. And what I want to do is take the current speed divided by the max speed and use our velocity and divide it by whatever we get from the current speed divided by our max speed. The shorthand notation for that would just be divided by equals current speed divided by max speed. And I also want to take a look to make sure that it's not moving too slow. So if current speed is less than min speed, then I'm going to go ahead and, whoops, let's close this off. Go ahead and grab my rigid body and do almost the exact same thing. Except now, instead of doing the current speed divided by the max speed, I want to do current speed divided by the min speed. So let's go ahead and save that off. We'll head back into Unity. No errors, so I'm going to go ahead and clear. Actually, let's just hit clear on play, so every time we hit play, it actually clears for us. I'll start this up, and it comes flying down, and we notice we get an error here. And it takes a look, rigid body velocity assigned attempt. So this error, basically what it means is if we come over here where we're checking the min speed, we can just add a simple command here. Let's check to make sure that our current speed is still greater than 0. And we'll come back in and hit play. Everything should clear. And it hits and just stops. But we did not get an error. I'm actually going to restart it just to see what the current speed is, because it did go by pretty quick. We'll probably want to slow that down. So yeah, it was 15 before it hit. Great, but it's not bouncing. So let's go ahead and actually fix this. Now, in order to fix this, we're going to have to create what's called a physics material. And we can come down here. It's right here, physics material. And call this what you want. I'm just going to call this my ball physics material. And I'm just going to call it a PMAT. And this actually looks a little bit different than what I'm used to, but I haven't actually used a physics material in a while. I guess it's physics material. I'm going to have trouble with that. But anyway, it looks a little bit different than the last time I used it, but the basic things you want to do is set your friction to 0, static friction to 0, and put the bounciness to a positive number. And then how do we want to take into consideration the friction combined and bouncing? Since we have no friction, it really doesn't matter. Well, I guess it does matter depending on what you're cladding with something else, but I'm going to leave it at average. Bounce combined, we have the exact same options, and again, I'm just going to leave that at average for now. And that's everything actually we need to work with the physics material. So I'm going to go ahead and select my ball. We'll take our physics PMAT that we just made, and we're going to go drag it right into the material here. and just drag it in. That's it. I just want to quickly check my rigid body, make sure the gravity was off. Everything looks good. Let's go ahead and hit play again. There we go. We now have our ball bouncing. It's bouncing a little fast. I'm going to shrink some of these up. Shrink them all up. I just want to watch the speed. The speed is quite a bit faster. If I slow this down to 5, that's probably a good enough starting speed for this level. And to be honest, 10 will probably be about the highest we ever want it to go on this level, since it is level 1. So I'm actually going to go in and actually change these values. So 5 to 10. Now you're going to want to watch out for some instances where things can get a little too fast. If we start these up, you can get it where it actually, in this case here, if we start it back up, it goes so quick that it ends up, let's select the ball here, you notice right here, it ends up gliding through the top wall and it just keeps going. You don't ever want to get that fast. There's ways to kind of use ray casting to get around that, but honestly, just working with scale, you can usually get around having to do any sort of ray casting whatsoever. So I'm just going to go 5 to 10, which should be more than fast enough. So that's 5. That's the slowest speed it's going to go, and that's fine. Let's work on increasing the speed when it hits. So I'm going to come down to this on collision enter, and I just want to add a little bit of speed to what I'm going at. And there's a lot of ways to do this. I'm just going to add a multiplier to it. So let's grab the velocity and, well, let's just add on to it or multiply onto it some modifier. And I'll go ahead and make this public. And I'm going to put it right above everything. It will be a float, and I'm just going to call it multiplier. And I'm going to start off with, I don't know, maybe 10%. That seems decent. And we'll come back down to the bottom here. And actually, I did that a little bit wrong. I'm actually going to change this. I'm going to make the multiplier 1.1, because what I want to do is actually add 10% to the speed. And this isn't going to be a multiplication. This is going to be an addition. And what I actually want to add to it is the rigid body. If I can spell it right today. I like it when my auto complete finishes. And I'm going to take the velocity and I'm going to multiply it by my multiplier. And that should be good. Let's go into Unity. I'm going to select my ball. We'll clear this out. And my multiplier isn't right because I did change it. If you notice in the script, it is 1.1. I want it to be 1.1. And let's start it up and pay attention to the current speed. It should slowly go up. So it is going up by, well, 10%. And it should stop at 10. And there we go. So if you want it to actually, increase faster, just increase the rate at which it goes at. So if you want it to go by, 20% increase, just do 1.2. If you want it to go slower, just increase whatever, the number after the decimal. But anyway, we have that working. There's still quite a bit here we have to add in, but there's a few things that I want to start working on with our other parts before I complete the ball script. So we're going to call this part of the ball script done, and we'll come back a little bit later on after we get a few of these other elements in place. So with that, I'll see you in the next video. Bye-bye.